Hello, magandang araw. I am Teacher Melvin, and again I welcome you to this new video as requested by my friends and colleagues in the Department of Education, General Santos City. So for today's video, we're gonna discuss t-test, one of the statistical tools most often used in research. So if you are a student who is taking your statistics or methods of research subject, or might be a teacher who would like to conduct a classroom-based action research, I tell you that this topic would really be of great help to you. And by the way, we're not gonna do the manual computation of the t-test, but instead we're gonna make use of the Microsoft Excel application to generate our data and results and interpret them afterward. To start off, I'd like to give you a little background about the t-test. So t-test is used to determine if there is a significant difference between the means of the two groups. I'll bring you in the context of education and instruction because I myself is a teacher and I think I'm more comfortable of explaining it to you in this context. So as a teacher, I usually provide diagnostic tests for my students. This is for me to identify which particular skills or topics my students are struggling with or having difficulty to learn. So in simplest term, I usually give them pre-test and post-test, and I gauge their scores or their performance using the mean scores or their average scores. So this is computed through the mean scores. So what we teachers usually do is just we get the difference of the post-test and pre-test, and sometimes if we can get a positive result, we teachers become complacent with the result and we come to the conclusion right away that our students have improved without considering that the result we get might be due to some chances. So this is one thing that we miss to consider. We do not realize if this result is meaningful enough to say that our students have performed well from their previous performance. But the thing is, this is not actually backed up by statistical evidences. So this is something that we have to consider. When we present data, it should be presented with confidence along with statistical evidence so that we can be more confident with the data we are providing our authorities. There are three main types of t-test and I'm gonna discuss briefly each of its type. First is the one sample t-test, which is used to determine whether the sample mean is statistically different from a known or hypothesized population mean. Say for example, the National Achievement Test. The average students in the country got a mean score of 60%, and we wanted to know if our students in our school are performing the same, performing below, or performing better than the average students in the country. So if we wanted to test how the students are performing, actually we can make use of the one sample t-test. The second type of t-test is what we call the dependent t-test or t-test for paired samples, which compares the means of two variables for a single group. So in this kind of t-test, we only deals with one group. And in the context of instruction, we might be dealing only with one class or one section. So for example, we wanted to know, does internet access in the computer class have instructional effect on student academic performance? So we wanted to know their performances before and after the internet access was provided to them. So we can get their performance without the internet access and the performance with the internet access. So we are just dealing with one class or one group of students. And so in this case, we can make use of the dependent t-test or t-test for paired samples. The last type of t-test is the independent t-test, which compares the means of two independent groups or two unrelated groups. So if we wanted to test two groups like male or female, so we can make use of the independent t-test. Or if we wanted to test an intervention with two groups, so we wanted to employ only the intervention with one group, or what we call the experimental group, and the other group with no condition at all or without the intervention, we call it the control group. So we can make use of the independent t-test. And now I'm gonna show you how to do the t-test using our Microsoft Excel application. But before we do that, there is one important thing that we have to do. We have to activate or install the data analysis tools in our menu. So how do we do that? Let's go first on the menu and press File in the upper left corner of our screen. Then after, let's go to the options and click add-ins. Now if you can see at the bottom, we can see here the manage Excel add-ins, and let's press go, and we can have this one. We will just check the two boxes with the analysis toolpath, then just press OK, and we can check on the data here, the data analysis tool. So this is the most important functions that we're gonna use to do the t-test and other statistical functions that we need for this video. Since everything is now set, first I'm gonna show you how to do the one sample t-test using our Microsoft Excel application. We have a problem. Does the mean scores of the sample differ from the average scores of the grade 6 learners in the National Achievement Test, which is 73.25? So just a brief review about one sample t-test. We use it to determine whether our sample mean is statistically different from our hypothesized population mean. So in this case, our sample mean are the scores from our 15 grade 6 students in our school, and our population mean is the average scores of the grade 6 students in the National Achievement Test, which is 73.25. So our null hypothesis is there is no significant difference between the sample mean and the population mean. So in order for us to do that, we will copy first the hypothesized population mean to this column, and we drag it out to fill the cells with the same values. And after that, we will go now to our data analysis toolpath. Then we're gonna choose the two sample assuming unequal variances, because there's no options here to use the one sample t-test. So we're gonna use this instead. So first, we have to highlight our first variable, which is the score of our student, and second is this column. Then for our hypothesized mean difference, we just type in 0. We check the labels because we included the first row for our labels, and for our alpha we have to key in 0.05 because this t-test will be tested at 0.0 or level of significance. And for our output range, we're just gonna place it here. Then just have to press OK. Then we have this data. So having this data, we have to highlight the three important information generated, which is the t-stat, the two-tailed, t-critical, two-tailed. Now in this problem, we choose the two-tailed because our problem is non-directional. It doesn't say that our mean score is above or below. It doesn't say anything. What we are into is just to determine if there is a significant difference in the mean scores of our sample and the hypothesized mean scores. So we're gonna choose the two-tailed test. So there are two ways to determine whether we reject our null hypothesis or accept it. First, we have to see if our t-statistics is greater than our t-critical, or we have to see if our p-value is less than 0.05. So if the absolute value of our t t statistics is greater than the critical value, we have to reject our null hypothesis. So in this case, we can decide now whether to reject or accept our null hypothesis. So the absolute value of our t statistics is 17.6017, which is greater than our t critical, which is only 2.144787. And our p-value, which is 0.00, is less than 0.05. So we can now reject our null hypothesis. So if we are going to look at our normal curve, so this is using our p-value, which is 0.05. So since the value we got is 0.0, so it falls somewhere here or here. So meaning it falls on the area of rejection. And if we're gonna use the statistics and the critical value, so the t critical value is somewhere here, which is 2.14479 or 2.14479 on the other side. So since it's 17, so it falls somewhere here. So we can decide now that our null hypothesis should be rejected. So for our conclusion, there is enough evidence to infer that the mean score of the sample is significantly different from the average scores. And now to explain it further, we can actually generate another set of data. So let's go to data analysis again, and let's use the descriptive statistics to find out how different our data is. So here we have to choose the mean scores of our samples, then check the labels, then the output range will just be placed somewhere here. And so as we can see here, how is it different even looking at this data? So let's drag it up here. So you can see the minimum value is 31 and the maximum is 50.75. And nobody from our sample means got the same scores or higher than the average national scores of the grade 6 learners in the National Achievement Test. So I think that what makes it different from our hypothesized population. So there is a significant difference in the mean scores of our samples and the average scores of the grade 6 learners in the National Achievement Test.